and welcome. So you've obviously attended today because I'm talking about observability, so I'm going to make some rather bold assumptions about you guys around your jobs, probably SRE, DevOps, that kind of thing. In fact, show of hands, DevOps people. Cool. SREs? Okay. Oh, what else could there be? Like network admins, sysadmin types? None? Okay, that's not, that role is now dead. Good. Okay. So what else have we got? Software engineers? Okay, cool. Okay, that's about right. So it's a mix. Nice. So today we're kind of talking about an architectural pattern, also a data management process, kind of a philosophy as well around how to look after your data in a bit more of an efficient way. And also, why should you care? Like, why should it actually matter to you? What is the problem? Why does it go on? And also then we'll expand that into a series of Amazon tools and architectures that will help you to deeply understand how you can implement this yourself. And hopefully that will give you some really useful value today and you come away with some really useful insights on how to build a solution like this. So yes, narcissistic slide about myself. I'm Chris. I've been an SRE, Java engineer. That was a dark period in my life. Then I moved to Golang engineer. It's much nicer. I'm principal engineer. I'm now responsible for advocacy at Coralogix. Coralogix is a full stack observability platform. I'll tell you a bit about that in a while. But the idea is that we are processing APM data, browser data in the form of real user monitoring, SIEM, so security, incident event management, infrastructure monitoring, log analytics, blah, blah, blah. However, we do all of it without a traditional index. That's kind of our little twist. That's our secret sauce. And it's been a hard-won architecture. It's been a hard-won feature set to actually go after this and learn deeply about what's going on. So that's kind of the story today. And then also, how would you build it yourself? What are the kind of tools that are relevant? That kind of thing. We're going to break it down into 3 stages. What's the problem with traditional indexing? What's the alternative to traditional indexing? And what is the impact? What does it matter? Like, why should, like, again, if you get rid of your index, you can say, great, I'm doing indexless observability, high five your friends. What does it actually mean? How do you sell this to your boss, in summary? I suppose if I'm going to say we're eliminating the traditional index, I should start by defining the traditional index. I feel is an appropriate place to begin. Who's done any DBA work or set up databases, that kind of thing? Hands up. Set up a database, had to care about data management, that kind of boring stuff? Okay, so in summary, when you run a database, you create your tables, you create your columns, and then you create your indices. You index the things that you care about. In summary, a user ID might become a primary key and therefore indexed. A team ID, a department, whatever it is. The things on which you may query become indexed. If it's not indexed, you can still access it, it's just a bit slower. And that's how databases have ran for years and years and years and years. And it's a pretty good model. It works really, really well. And so in observability, of course, we completely ignored that and we just indexed absolutely everything. We thought that would be a great idea. So the reason why we did that is for a number of different reasons. But the essence of it is when you put your data into, say, an OpenSearch cluster, into an Elasticsearch cluster, whatever it is these days, they will track every single field, the type of that field, and in many cases, every value in that field, the cardinality as well. This is fun. And if you were to say to your DBA, I would like to index every column in my database, I would recommend ducking briefly after because something's going to get ahead. So the reason why is because database administrators learned that as the scale of the data increases, that index-first approach just does not work. You have to get clever about it. You have to be more responsible with how you roll out your indices. So why? Why should you care? Well, firstly, why has the data increased? Why have things gone up? I'm going to use this laser pointer because I didn't know I had it. Nice. So microservices. More services, more tools talking to one another, more failure modes. If a microservice fails, it doesn't necessarily blow the whole system up. It just quietly dies. And then the queues start to back up, databases start to increase, load times start to increase, and so on. But there's no giant fire anymore. If you've ever administered a monolith, it's a bit of a simpler existence. Either everything is completely on fire or everything's probably okay. That is not the case with microservices. That drives up the need for data and also the complexity of that data. So you have to have much more complex data with more correlative fields so you can understand everything that's going on. The cloud, is fun because we can just spin up instances left, right, and center. Also, we can spin up different instances that specialize in different things. If they specialize in different things, then of course, they don't specialize in others. And it's only a matter of time before they're used for the wrong reasons, they break, and so on. Again, drives up the data complexity. And the final point is compliance. This is one thing people don't think about when they think about data problems. The European Union, for example, has released several, over the past decade, have released lots of new legislation to make sure that organizations are being responsible with their data. But recently, the DORA legislation, I heard of this one, so this is going live January 1st. This says it's about IT providers and finance companies, and they have to retain their data for longer, much longer under DORA legislation. They also have to have effective access to that data. It's enshrined in the legislation. They have to also have decent data coverage to cover their operational needs. Nice vague terms, but the point is that this is the first time in history where there is a mandate for a minimum amount of data coverage in your organization. So it's one of those dimensions that people don't think about. They think about the technical reasons that are driving up data footprints, but there are big legal reasons as well, and that's a big problem. In summary, Index First was great in 2010. Actually, it was okay in 2010. 2004, it was brilliant. Later on, not so good. And we've hit a point now where many of you are here. Many people that we speak to at the booth, we have a booth in the expo hall, are saying to us that we're actually really struggling with our costs. If we've ran the infrastructure ourselves, we're struggling with performance. We keep dealing with mapping exceptions, or what we call mapping explosions, which is a problem in Elasticsearch and OpenSearch where it just has too many fields. Mapping exceptions are where the type of a field has changed. In summary, indexing everything is rigid, expensive, complex, and painful. So the first objection that I always get when I talk about this topic is, well, I need the index. How am I supposed to access things if I don't have the index? I just want to test that. I just want to get into that very, very briefly. Firstly, we ran a massive meta study. We actually reran a smaller version of that study. 99% of the index observability data is never searched. I don't know if you guys know much about indexing, but if you index something, the whole point is so that you can search it. That is literally it. If you don't search it, that is a lot of wasted money, a lot of wasted compute, a lot of wasted storage. And 30% of the data is just not used at all. So maybe the problem isn't necessarily that we have way too much data. Maybe the problem is that we are maybe not as optimized with how we use that data. Maybe we're not as clever as we could possibly be with how we get that data across. In summary, telemetry is noisy, complex, and largely underutilized. I attribute that to myself in this very moment. Congratulations, you've seen the birth of a quote. It's always good. Nope, that was a laser pointer. Oh. So, I'm talking about indexless observability and getting away from your index and blah, blah, blah. I think I should probably make it more concrete. Principle number one, your logs and traces are in a database. This sounds kind of dumb, but again, if you were to take a database and index every field, you would be accused of being insane, probably quite rightly. So when we index all of our fields in our logs, when we index all of the fields in our spans, less to do with metrics, because obviously they're handled in a slightly different way, you have to think about them in terms of a database. How am I going to query this data? How am I going to access this data? How is it going to be used? This is a fundamental principle, because if you don't know how it's going to be used, you're going to really struggle to optimize. This is how databases work. In databases, we talk about how the data is going to be queried, and we index for it. Principle two, everything is queryable in seconds. Everything is where I put the emphasis here. Not just the index data, but the unindexed data as well. That's the case with most databases, by the way. Most databases, if you index the data, you're looking at sub-second, double-digit millisecond queries. And if it's not indexed, you're looking at a few seconds of processing time and maybe a slight spike in both the blood pressure of your DBA and the CPU of your DB instance. Everything has to be accessible in seconds. That's a really fundamental principle. Observability use cases are not the same as like big data transformation use cases. Big data, they're happy to wait 10, 15 minutes for a job to run. Observability data, you have to be able to access it in seconds. Nobody wants to sit at 3 in the morning watching a loading spinner on their queries. If you've been woken up, you need to see this data. So indexing equals speed, not availability. So when we have this option of, we can index it so we can query it, and if we don't index it, we can never access it, it's not going to work for observability. All that does is drive people towards indexing, because you never know which data you really, really need. Principle 3, you can't compensate with rapid storage. So all the queries just running a little bit slowly. Let's just throw more fast storage at it. At the very best case, you have a Band-Aid. The very, very best case, you have a very temporary solution to a consistent, persistent problem. You're going to have to do something about it sooner or later. And so principle 3 is the complete negation of what people often do. You have to be able to trust slower storage. And that's all about how you manage the data, all about how you control the data, the format, and so on. We can talk about that in a moment. Ingestion is only the beginning. So a big, big point of what I'm going to emphasize is, let's say you have a log that comes from your CDN. You have a CDN solution. Who's using a CDN? Just give me an idea. Like Cloudflare, CloudFront. I'm seeing a lot of nods. Yeah. So it's actually quite rare to sift through the logs of a CDN provider. You don't do it very often unless there's errors. You totally don't sift through the 200 status codes. But it is very common to want to know what the average latency is at any given time. Every log that comes from a CDN provider, when it handles the request and response, has a latency metric in there. So pull the metric out. You don't have to index the original log, just transform it into a metric and hold it on the side. Metrics are extremely efficient, very, very low memory footprint, very low disk footprint, and as long as they're not super high cardinality, very low CPU footprint as well. So your logs can be there as your true record of what happened, but for your observability use case, you transform into something much more low footprint. Metrics are unique as well because they're indexed, but in a very, actually like databases. You put the labels on the index for the dimensions on which you wish to query. You can't have lots and lots because it will slow things down, so you have to think in a use case driven way. I always find it really strange, by the way, that we can take this thinking and we apply it to metrics and it's completely natural, and then when we get to logs, we'll like index everything, we just in case, you know? But this is all it is, it's just a transference of that thinking. And principle 5 is you own your data. When we talk to a lot of customers who are moving from various different platforms, being the advocate, I get to go to lots of customers who are implementing lots of different observability solutions. And what I find, more than the subscription cost of some feature in the solution or something, it's the storage costs that are killing them. Every customer I talk to that has like a plus 1 year retention on their logs, for example, for security reasons or for regulatory reasons, it's that's killing them. Storage cost will get you. However, you need the data. You really, really need the data. It exists for a reason, especially if there's like a legal, regulatory reason. You have no choice. You have to have the data. Some people will say, well, I'll put it in Snowflake, I'll put it in whatever. You have to have it somewhere close to home. So something like S3 is a nice place. It's a nice middle ground. You don't have to run the disk. You're paying for very low cost storage. The idea there is that you have the data in your account. You can do whatever you want with it. You could start a bloody GPU farm and train a machine learning model with it if you want to. You can do whatever you like. You can print it out on A4 sheets if you really, really want to. It's yours. It has to be your data. The data is the lifeblood of your company, especially in 2024, whole advent of generative AI. You need data to train those LLMs to convince your investors that you're doing great. That's the game. So principles are great, but we're all here, AWS reInvent, because we want to know how to apply this in the real world. So I'll talk to you a little bit about a well-known architecture, a kind of approach to how to hang this together, and also some of the drawbacks and some of the benefits of said architecture as well. This is fun. There's a lot going on here. This is a very, very good time to use my little laser pointer. Up here we've got OpenTelemetry. Hands up if you've heard of OpenTelemetry before. It's like half the room, okay, and some people haven't. So OpenTelemetry, just to make sure we're on a level playing field, is a open source telemetry collector. Why would you need an open source telemetry collector? Because your alternative is to use a vendor-specific telemetry collector. For example, if you use Splunk, Splunk has a collector. If you use Datadog, Datadog has a collector. The problem becomes really apparent when you're doing APM and traces, because it gets into your code base. So migrating away from that becomes very, very painful. You're nodding a lot. I'm guessing yeah, I can feel the pain. It's okay, man. So the whole idea is using OpenTelemetry is almost like a piece of middleware. It's almost like an abstraction layer for your vendor. We recommend this. In fact, when we migrate people to Coralogix, we just use this. Because A, it's great. It has an amazing community around it. It's fully featured. At times, maybe a touch memory heavy. So you have to make sure you configure it right, which is why we have a bunch of engineers that know how to do it. But ultimately, it works really, really well. And you can get all of your key data types with it, and the vast majority of vendors integrate with it. So you're not losing any functionality, but you are gaining that all-important abstraction layer. And that abstraction layer gives you the ability to negotiate with your vendor, because you can realistically leave. Let's say you migrate to Datadog, whatever, and you don't like what you're seeing, you change a few lines of config, you roll it out to your collectors, and suddenly you're using a different vendor. That's a very different conversation from, well, we've put the Datadog collector in our entire code base, and we've instrumented it in a custom way. And now migrating away is like $1 million and 6 weeks of dev work, we see that all the time, by the way. So OTel, brilliant for that respect. Then we have Kafka. Why Kafka? Kafka is great because it's very, very high throughput writes. So the vast majority, this isn't, in comparison, this is not read heavy data. This is write heavy data. You're producing a ton of logs all the time. If you have any reasonable scale, you're producing a ton of stuff all the time. Kafka is great because it's very write optimized. It's also great because it allows you to hook in various different consumers of various different data topics. You can actually build a really, really clever set of transformations. Remember before when I talked about CDN logs and I was saying it has a latency metric, so extract it. You can put some transformation logic off the back of your Kafka instance. Also, the reason for Kafka as well known, well understood. It's not, I won't say it's easy to find experts in Kafka, but they exist. They're out there, It's much better than cooking up your own, whatever, in Golang or whatever, some crazy thing, or using some really niche solution. There's really, really high performance solutions like NATs, which are very, very high performance queuing, but finding someone who knows them is very hard. So this is kind of a nice middle ground. Kafka's well understood, it's well known, it's a good technology, and crucially, it works really, really well. It's consistent. I'll talk about some of the problems in a minute, but generally speaking, it's very good. And then we have Amazon S3. Why? S3 is generally a protocol that's adopted by almost all. So in some cases, most tools will integrate with it. That means that if you have some big plans for your data, the chances are they will read from S3. It's not just about having the data, it's about having effective access to the data. That's what this indexless idea is all about, actually, is maintaining effective access. And that means that it's really important to choose tools that have clear integrations with lots and lots of different downstream and upstream, so writing to it and reading from it. Then we have Athena. So this is the slightly controversial one of the pick. Athena is a tool that will, it's not a traditional index actually in the same way that Elasticsearch is. It will keep track of some fields, but it treats it more like a kind of loose database. It will allow you to query your data ad hoc at will. There are some downsides to this, by the way, and I'm not here to sell indexless observability to you, to be honest. I'm just here to present the idea, and hopefully it resonates with some of you. So there are some problems with this, and I will be honest with them. And finally, something like Thanos, or a Prometheus instance is okay as well. The reason why Thanos is nice is because you can push to Thanos Gateway, and it will store metrics in S3. Metrics in S3 can be queried extremely fast. We built a product around it, actually. So the speed is basically down to the fact that metrics take up very little disk space, and S3 is very consistent. So for example, if you query a gigabyte's worth of data, it's a few milliseconds. If you query a terabyte's worth of data, it's a few milliseconds. It's very, very consistent across request times, and this consistency makes it much more predictable and useful. Makes it good for the observability use case. So what we're looking at here is left to right, we're looking at the way the data gets in, basically to S3. S3 is your source of truth. And then we're also looking at how the transformation happens. So you could, for example, have Kafka consumers. In Lambda functions, you can do that. If you want, you can do it in instances. Here's what I would say about the choice of technology for the transformation logic, by the way. On average, it's about 4 times more expensive per CPU second for a Lambda function than it is for an EC2 instance, roughly. So when you're choosing this, make sure that if you have constant data going into that transformation logic, maybe Lambda isn't the most cost-effective solution. Maybe running an EC2 instance is a better idea. Lambda functions generally are great for ad hoc and spiky workloads. Consistent workloads, you might want to consider a server-full solution, for lack of a better word. And then if you really need to, you can always add the index. So stick OpenSearch over the top for some of the really, really key data. For example, the example I like to give is like errors in your payment system. This OpenSearch instance, for example, will be really easy to manage because it's only got a little bit of data in there. It only gets painful, by the way, when you have lots of data in there. Why? Because it's indexing everything. If you keep the data really lean that's going to OpenSearch, you'll have very few operational challenges with it. Make your life much easier. And you can use high-performance SSDs for them if you really want. So I will say that this dependency on this kind of solution is disappearing. It's going away. But in the meantime, if you need it, you can always do it. And because of something like Kafka, because of something like OpenTelemetry, in fact, in OpenTelemetry, you can say this app is going to be pushed to this receiver or this exporter, and this exporter goes to OpenSearch. This app's logs here, they can be pushed straight to Kafka and go to S3. You can push everything to Kafka and then route some of it to OpenSearch. You have lots and lots of configuration options here. But the point, the principle is the same, which is your index becomes the exception to the rule. And kind of like the same way in a serverless architecture. Serverless isn't really serverless. It's just that your first port of call is to not use your own server. And it's exactly the same principle here with Indexless. Your first port of call is not to use your own index. However, there's always a drawback to everything, so we might as well get into those. Firstly, Athena. So I'm obviously conscious that I'm at an Amazon conference, so I feel like a red dot will appear here if I say too many bad things about Athena. But the thing that's generally not good is it's very easy to rack up costs in Athena. So you have to be careful about what you're querying. There's two reasons why this is bad. Obviously, unexpected costs, difficult to budget for, not good. Also, it freaks engineers out every query they run. And you really don't want to be scaring engineers away from exploring their data. Otherwise, the ROI on every gigabyte is much less. So really, what you want to do is encourage people to use it as much as you want. This is an impact of Athena. This is a problem with Athena. There are lots of other solutions out there, by the way, but this is just the reality of the situation right now. This is a technology we have available in the AWS stack. If you know, by the way, if you're running the same constant queries over and over again, you're probably okay. I will say that if you decide to implement something like this, you will get, your Athena cost will look something like this. This is a graph. It will look something like this because you're experimenting and you're running tons of queries to work out what's going on. And then it will kind of peter down and it will hit some sensible medium as people work out what queries they need and what they don't. And then occasionally the odd spike when an intern runs a script they shouldn't run, but we can, that's life. Kafka at scale is scary, very scary. You can have all sorts of weird, wonderful things go wrong with it. So the scale that you've taken away from OpenSearch might actually come back to hurt you a little bit in the Kafka side of things. You can solve this problem, by the way, by using something like Kinesis. Amazon Kinesis has much of similar functionality, fewer integration points, but it's still pretty good. Kinesis will take away a lot of that server management for a fee. So if you don't mind the operational cost addition, it's not so bad. If you have experts in your company on Kafka, the chances are you're not going to have too many problems. The problem is Kafka experts, a little bit expensive. You're paying somehow. So again, such is life. And the transformation logic. Often, I want to know very fast, so going back to my CDN example, let's say you have a function that is transforming your CDN logs into a latency metric, an error percentage metric, and then it's pushing them back into Thanos. That is latency. Latency is the enemy in observability. You do not want to know 10, 20 seconds after something's happened. You want to know right away in real time. So your transformation logic can become a bottleneck. And that's a big problem. You have to make sure that you pick the right way of doing that. That's why I tend to lean towards lambdas. And I would recommend lots of small lambdas because they will be themselves spiky. The data is consistent, but the jobs of each lambda will be spiky because they'll handle different types of data. And that will generally mean you get the benefit of serverless cost optimization as well as not having to manage the servers themselves and the concurrency. Fun fact, I think this is still the case that Lambda has a limit per account of 1,000 concurrent executions. So if you have lots of different types of logs, then you may hit that. I believe it's a soft limit. I found out the hard way. It was not nice. Do not find out the hard way. Trust me. There's some gray hair on my head. You can't see it. That's where it comes from. So, of course, hence the brand name on my chest. If this seems like a lot of work, it seems like a lot of risk, a lot of knowledge to learn, that kind of thing. The reason why I'm so confident in this as a paradigm, the reason why I'm so confident in this as a philosophy and a way of approaching your data is because we've built an entire product around it. This is the core of the Coralogix product that you're looking at. So rather than building all this stuff, you can just roll Coralogix. We roll with OpenTelemetry by default. We roll out across, we use Amazon S3 in your account for storage. And we use Kafka actually internally. We've just done the hard part of hiring a ton of Kafka experts to make it run really, really smoothly. So that's our problem, not yours. It's great. Just so you know this about us, by the way, we're not tiny. Launched 2017. We're thousands of customers. We're deployed globally. GovCloud, you name it, we're there. The idea behind this slide, by the way, just so you know, it's not like a two-guy startup in a garage somewhere. There's 400 people in the company now, over 2,000 customers globally. And they're happy customers, I will say, because I meet most of them. So I can say that firsthand. When I talk about all the different options, by the way, in summary, APM, RUM, SIM, whatever it is, we support it. Everything from all the way from the browser through to the backend database and every single thing in between, the network infrastructure, gosh, everything. And there's an announcement coming in a couple of weeks, by the way. I'm not allowed to say anything now, but it will be really, really cool. And I really want to tell you because, yeah, but I can't tell you. So in a couple of weeks, it's going to be really nice as well. There's going to be a whole series of new lines on this diagram, but yeah. Pricing is really consistent, straightforward and easy to understand. We charge by gigabyte and only by gigabyte. Not even for support. Support is free. The way we do this, by the way, is really straightforward. You're able to pick the value. So you're able to say, I want to index this data. I don't want to index this other data. So, and what does that mean for you? What does that mean in concrete terms? If you move, for example, from Datadog to Coralogix, most customers will see between a 50 and a 70% cost reduction. If you move from Splunk, it's a bit more difficult for us to say because Splunk doesn't publish their pricing, but it's significant. We're talking like the 50 up to 80% in the Splunk world. Almost every major SaaS vendor is index first, and therefore they are more expensive than we are to run. We can push savings to our customers that they can't. And that's based, by the way, on this philosophy that I've just talked about, indexlessness. This is the big brainwave that our CTO had a few years ago. I mentioned the ability to cost optimize. There is this is an example from, anyone used AWS MediaTailor, by the way? Is this familiar to anybody? Any hands up for MediaTailor? Any media streaming stuff in the Amazon platform? Yeah, a little bit, okay. So MediaTailor is an example, very, very log heavy. And so what it means is that most people can't ingest the logs. We are now seeing a massive adoption, we're rolling forward of this particular use case. And it's the same, by the way, for CloudFront CDN. Very log heavy. So rather than charging for the logs, what we say is, hey, go 100% monitoring level, which is no indexing. You can trigger alarms, update dashboards, generate metrics, and then not index it. Just push it to S3 at the end, and still query it directly. The browser monitoring, so we can put an SDK into your front-end application, and then, I'll use my trusty laser pointer, this little trigger here, the show archive, this means query directly from S3. So without that, the whole page loads in like under a second. With it, the page loads in about 3 seconds. And we're querying directly from S3, pulling all that data. And that includes, by the way, really cool stuff like session replay, which is by default ingested at the monitoring level. What this means, by the way, is we're about like 20% of the cost of CloudWatch to contextualize what that kind of means in terms of data costs. APM, so again, we're covering the full APM stack. We're tracking even custom things like at-dex scores to look at the usability of your APIs. We're tracking the latency, error rates. We're looking at the most time-consuming requests. We're even showing you every individual trace and transaction, all of which can be driven because a little show archive button. Pull from S3 if you want. A lot of our customers now, by the way, have that on by default because most of their data is held in the archive. Deep analysis of data in your cloud object storage. So we have a really cool query language. This is called DataPrime. It's like if you imagine if anyone's got like used Splunk in the past, it's the Coralogix's answer to Splunk query language. The difference is that we don't need the data to be indexed in order to query it. So this is a query running directly against the index. In this particular case, we're grabbing IP addresses that are not in a certain subnet, and then we're correlating a WAF block event with the HTTP traffic that came from CloudFront. So just to give you an idea of what can be done in the platform. Up top here, we are getting distinct source IP addresses that are not in a certain subnet as well, the 10.8 range. So it's really powerful. There's a bunch of really great functions in there. I recently wrote the documentation, so if you go to the docs and you really enjoy them, you are welcome. So the idea, guys, is just index first is kind of is one of those aging things. It survived for as long as it has because many things survive longer than they should. Myself included, no. But the principle, the idea is to be more responsible with our data, treat our telemetry data as if we're database administrators, and hopefully reduce our costs, but also improve the usability of our platforms and become better, more efficient, more effective at operationally running our workloads such that we can sleep better at night, not be woken up by alarms at 3 a.m. And we can do that through the wonderful power, the wonderful brain of our CTO and co-founder, Yoni Farron. And yeah, so that was hopefully a useful introduction to an idea around indexlessness and how Coralogix delivers that as well, and also provides a series of really great cutting edge, like sort of future-facing APM, RUM, SIM, and so on, but does it without the burden of an index, which massively drives down the cost, but also massively improves the amount of data you get access to, where the data is held, and what you can do strategically with that data once you've got it. It's not held behind some corporate ransomware paywall. It's there for you. So that is everything I've got to say. Thank you very much for coming along. I really appreciate it. And if you have any questions, I'll be hanging around for a little while afterwards. But thank you so much for coming along. Cheers, guys. Thank you.